Hello everyone. Today I am presenting my project titled CPU Architecture Simulator CISC versus RISC versus RISC-V. The main objective of this project is to visually demonstrate how CPU architecture executes instructions and how they differ in terms of complexity, performance, and design approach. Instead of only explaining the theory, I have created an interactive simulation where we can actually observe how instructions flow and are processed in each architecture. This makes the concepts much easier to understand and more engaging. Now we will enter the simulation. So, as we can see on the screen, the interface is divided into three sections. On the left, we have CISC, in the middle we have RISC, and on the right we have RISC-V architecture. Each section represents a different way of executing instructions inside a processor. I will now explain each architecture one by one using the simulation. Let's begin with CISC, which stands for Complex Instruction Set Computer. In the architecture, a single instruction can perform multiple operations internally. As shown in the simulation, one instruction is broken down into several micro operations, and these are executed step by step. Each step takes time, which means execution is sequential and more complex. This reduces the number of instructions needed in a program, but increases the complexity of the processor design. Because of this, the CISC systems are powerful but can be slower compared to modern architectures. So overall, CISC focuses on doing more work per instruction even if it requires multiple internal steps. Now we move to RISC architecture, which stands for Reduced Instruction Set Computer. In contrast to CISC, RISC uses simple and uniform instructions where instruction set is executed in a fixed number of steps. Here, we can clearly observe the pipeline stages: fetch, decode, execute, memory, and write back. The most important concept here is pipeline. Instead of executing one step at a time, multiple instructions are processed simultaneously at different stages. For example, one instruction is being fetched, another is being decoded, and another is being executed. This parallel processing significantly improves performance and throughput. In the simulation, we can see multiple instructions moving through the pipeline at the same time, which demonstrates this concept visually. You may also notice slight pauses or delays. These represent pipeline hazards or stall, which occurs when instructions depend on each other. Overall, RISC focuses on simplicity, speed, and efficient execution using pipelining, which is why it is widely used in modern processors. Now we move to RISC-V, which is a modern and open source instruction set architecture. Unlike traditional architecture, RISC-V is designed to be modular and flexible. In this simulation, we can see a central processing unit surrounded by different modules such as ALU, memory, and control units. The signals move between these modules dynamically, showing how different parts of the processor are activated based on the task. One key advantage of RISC-V is that it allows customization. Developers can design processors based on specific needs. This highly makes it suitable for modern applications like embedded systems, IoT, and different advanced computing. So RISC-V represents a scalable and future-oriented architecture. Now I will run the simulation. So, as we can observe, in CISC, the instructions are executed step by step with multiple operations. In RISC, multiple instructions are processed in parallel through the pipeline, where we can also see the stall happening. In RISC-V, different modules are activated dynamically. This comparison clearly shows how each architecture handles instruction and execution differently. So, in conclusion, this project highlights the key differences between the three major CPU architectures: CISC, which focuses on complex instruction; RISC, which focuses on fast and efficient pipelining; RISC-V, which focuses on modular and flexible design. By using the simulation and visualization, this project makes us understand this concept easier compared to traditional theoretical explanations. Thank you.